to transformations, and it depends on your application where you need it. Like here, I need cloth because it is three phase. I need to convert into two phase. Okay, here two phase to two phase, but I need direct and quadrant access. So I used park transformation. Okay, so now this is done. Let's go one step ahead. In today's class, as I mentioned, we'll be going through torque equation uh, quickly, and then we'll go to vehicle dynamics. Okay, let me
So
open the
sorry,
board.
one
Yes,
question, Narendra. So
yes.
the entire network or the strategy that we devised,
Hmm.
so that is that something that for the brushless DC motor, it's commonly available. Is this something that is there? When you go purchase
Yes.
a DC motor, it'll automatically come with it.
Okay, when you buy a brushless DC motor, like these days, companies they build the controls into it. For example, if you take what is the name of that?
It's an active feedback loop, right?
Yeah, there's an act. Yeah, see, so
So
they
continuously it controls
yes, right.
the magnetic field
Continue
so that peak
continuous
torque is
con-
already.
yeah, continuously they impart this control loop into the motor, and they provide you an they they are making it into a package these days. They give you the motor along with that control configuration. Okay, there are multiple ways, like there is an vector control. This is field oriented control. So depending upon the from what kind of buyer you're buying from, they try to incorporate one or the other technique in order to get the maximum torque out of
So one more follow-up question.
it. Okay.
You mentioned that some of the application is something like the drone for the drones for
Oh,
the rotor.
okay. Brushless DC
I-
motors, they're used for the drones. Yeah.
Is
They're
there a reason why it is used for the drones?
because they're compact in size with less, see how small they are. Even DC motor can be, DC motor, you can find it this small, but DC motor have limitations when it comes to speed and efficiency. They're
Okay.
simple, but they're very simple to build DC motors. Okay. I mean, DC motors, but they have limitations with the speed and as I said, if you go faster in speed, the brushes will wear off, they catch up fire and all that. Whereas here there are no contacting parts. So if you are able
Okay.
to build a very small one, then you can achieve high speeds by using these synchronous motors.
So maybe in a application where it is supplied power is from a battery, DC battery, it makes
Uh-huh.
sense to get rid of the inverter and just go with a
DC
DC
motor.
motor, right?
No. They generally, if the even though the power supply, say for example, if you take a car, electric vehicle, the battery is a DC. Still, we go with AC motors, right?
That's
Because
because of the rugged induction
yes,
motor.
yeah, because uh, no, see, some companies use induction motors, but most of them go with these permanent magnet synchronous motor or reluctance motor or switched reluctance motor, because synchronous motors have higher efficiency and there are no contacting parts. So that's the main reason. Even though the construction is the building them is difficult.
But I thought the induction motors are asynchronous motors, right?
Yeah, but still there are no contacting parts, right?
Yeah,
So
yeah,
you
true.
can
There's no wear and tear
so
will be
yeah, no wear
less.
and tear, and it's the AC power supply. So from the if you take a typical electric vehicle, the battery, they use an inverter electronic circuit, they convert DC to AC, and they provide it to the motor.
Yeah, they use a inverter
Inverter,
and yeah, yeah.
yeah, inverter and buck and boost converters. in order to uh, in order to provide
Supply
power
power to
supply
that motor. Yeah,
motor. Yes, you're right.
got it. Thanks, Narendra.
That's how that yeah that because just because one simple reason, efficiency and no contacting parts. Those two are the main things.
All these motors, they're more than 90% efficient, right? DC motor, AC motor, maybe.
Now,
Or am I right, or in that, or I mean, some
yeah,
motors have
yeah.
lower.
Motors. The research is really good on motors. Efficiency is almost near to 90 in most synchronous motors. Okay, so we need to look into the torque derivation. Okay, so uh, find it. Sorry, guys. Just a second. I placed it somewhere else. Ah, okay. Sorry, I was going through all the documents, so I misplaced it. Electronics phase, phase, excited, electronic. Right? Yeah. So this notes is already uploaded on the Moodle page. You can take a look. Okay. Quick glance. Uh, so it's really simple. So one reason why we could able to achieve rotating magnetic field is because of this sinusoidal pattern which we are which we incorporate when we are building a stator magnetic field. So once you have this sinusoidal winding, then the magnetic field developed will also be varying depending upon the winding. So for example, so the number of windings at any given point of time are like because of the sinusoidal pattern, right? So there is sine theta. So sine theta into ns by 2, where ns is the total number of windings. So if theta angle is like, for example, here it is uh, might be 20 degrees or 10 degrees, 30, 40, 50. So as the angle increases and the number of winding increases, as the angle reduces, the number of winding will keep reducing. Now, after now we know this is the resultant number of windings. Now let's take this the and let's derive the uh, torque equation for a simple brushless DC motor. So it is very simple. Just give me a second. Okay.
Narendra, only one question.
Yes,
So
please.
the windings that we have, the three-phase winding,
Uh-huh.
which
Uh-huh.
basically varies with the different slots, and then you have like a pattern. So is
Yes,
it
yes.
only for the uh,
Any kind of AC motor in order to
any motor
obtain any kind
that
in order to
RMF?
no, in order to obtain the rotating magnetic field, you need that winding.
Okay.
Okay, without that winding, you can't obtain rotating magnetic field. Okay,
Got it.
so
Got it.
without having rotating magnetic field, how will you make your rotor to rotate? You can't, right? See,
Got it. Got
the
it.
rotor is rotating because stator is either attracting or repelling the rotor from its position, right?
Yeah,
So
that's
if you're
clear, Narendra. My only doubt was, is this special winding only for the brushless DC motor or any of the other AC
even
motors also?
yeah, AC motors, most AC
Everything
motors
has
are,
the same
yeah,
thing.
yeah,
Okay.
yeah, they might have made some modifications from when they initially got invented, but basically they have this kind of winding.
Okay. Okay. Got it.
Yeah. So the you should understand the purpose of it rather than because we are we are not worried of how the winding is made. We are only seeing if the winding is developing rotating magnetic field or not.
Got it.
Yeah.
The primary purpose to obtain the rotating magnetic field.
Magnetic field. Okay. So
Thank you.
let's have a quick derivation. Okay. Now imagine take a reference axis. Okay. Imagine your rotor is at an angle of theta r with respect to the reference axis. Okay. Now the rotor will the rotor will follow the stator. Okay. As the stator magnetic field, the rotor also will move. So so
Sorry,
take the
Narendra, are
yeah.
you sharing the screen or?
Oh, sorry. I'm drawing, but I'm not sharing.
Okay.
Yeah. Can you see it now?
Yes, I can.
Okay. So here, for example, let's take this fixed stator frame or fixed axis. Okay. And the rotor is at an angle of theta r from the fixed state. Now, now imagine the rotor moved by an angle of zeta. Okay, the rotor moved by an angle of zeta. Now, if the rotor moves by an angle of zeta, so what will happen? The magnetic field also will change, right? Because the number of coils will change. The number of coils change because the coils are wound with a certain pattern. Because we follow this pattern when we are building the winding, right? So imagine the rotor is here initially. Take this as reference axis. Imagine the rotor is here. Okay. So if the rotor is moving from here to here, so windings are changing, right? So the if the windings changes, then the amount of current flowing also will change because the current we are providing, if you imagine a constant you're providing this power supply to the motor. Okay, now the winding changes, the current changes, then the current changes, the magnetic field, magnetic motive force or magnetic flux will also change. So how does it change? For example, we have this equation where uh, ns of theta is equal to ns by 2 of sine theta. Okay, sine theta. So here, or you can say sine theta or angle of the rotor. Now, now there is a deviation by zeta. Okay, there is a deviation by zeta. So what it will be ns by 2. Okay, sine of theta r plus zeta. Right, guys, are you with me? It's really simple, right? I'm
Yeah,
just
got it.
so what I'm doing, I'm just writing this equation where right taking this equation, we know the number of windings. So the number of
Mhm.
windings will change because the rotor moved to a different position. How it moved by zeta, so I'm taking this zeta into consideration. And
Mhm.
we have three we just don't have one winding. It's a three phase power supply, so we have three different windings. So each winding has a phase difference of theta p. Okay, So theta p. Oh, so the phase one is 120 degrees. They are 120 degrees away from each other. So what you can write, for example, if you have phase A and B, C. Okay. So for phase A, it is sine of theta r plus zeta. Okay, minus 120 and
Mhm.
ns by 2 sine of theta r plus zeta plus 120. Considering all the phases. So if so we have three different phases. For three different phases, you have three different windings. So I want to normalize it because I'm deriving the torque equation. So the normalized equation will be ns by 2 sine of theta r plus zeta minus theta p, depending upon the phase. Okay, phase is 0, then theta p is 0. If phase is 120, it will theta p is 120. If 30 phase is plus 120, then theta p is plus 1. Theta p will be plus 120. So depending upon the each phase, the winding at each the winding will be changing, and the generalized equation will be this one. Now we know that, okay, f is equal now. If you take the current is flowing through them. So into the phase current is the current carrying by each of those coils. Like if there are 10 coils, then one coil is currenting, like if there is a phase current of 1 ampere, if there are 10 coils, then there will be 10 ampere current. So into the current which is being path flowing into the coils. So into IP. So we know that F is equal to B I L. Flux, magnetic motive force is given by BIL, right? Guys, are you with me? So
Yeah.
B is the magnetic flux, I is the current, L is the length. Now substituting this. Uh, okay. Now what will be the magnetic motive force is nothing but it is so we know the number of windings, we know the current, and also torque is also given by uh, to- force into radius. So R is the radius of the stator, sorry, rotor. L is the length of the rotor. So torque is equal to P I L R. Are you guys with me?
Yep.
Mhm.
Okay. Now, now if the winding is changing, what is the major thing it is changing is the current, right?
Mm-hmm.
So the amount of current flowing, see, this is the winding ratio which we wrote, and we normalized it without IP. Once I add IP, then this is nothing but amount of current flowing, amount of current. So I is the current in the formula. If I substitute it, P into I is the current. So NS by 2. As the winding changes, the amount of current changes. So I'm multiplying the current with uh, the winding formula. Torque is the torque developed by the torque developed by the rotor when it is in when it didn't move, when it is in a particular position. But we need to integrate it, because here what I observed, what did I do? I'm saying, okay, the theta r, okay, yeah, this the theta r is the position. If it is moving by an angle of zeta, then this will be my torque developed. But actually, what's happening? The rotor is rotating 360 degrees. It's not staying there. So the total amount of torque is nothing but integration of this term. Total torque developed motor is nothing but integration from 0 to 2 pi b into ns by 2 sine of theta r plus zeta, okay, minus theta p into ip into l into r into d zeta. Because earlier I only considered that the rotor is moving from here to here, but basically it is moving from 0 to 2 pi. So what is changing? This zeta is changing. So I need to integrate this equation from 0 to 2 pi for all the three phases, not just the one phase. Here I'm just normalized it and I only considered it as one phase. Okay, guys, are you with me? See,
And
it's
I know just
really
one question, just only one
yes.
question.
Mhm.
What is the reason for the ns by two sine rotor theta plus zeta?
Okay,
Why is it like negative uh, theta phase theta basically?
okay, okay. See, if you observe here, the windings are made with a phase difference of 120 degrees from each other. Like
Mm-hmm.
you have three phases, right? VA,
Yeah.
VB, VC. Okay, so
Mm-hmm.
so each phase is 120. That's how um, like
Physical construction, right?
yeah, that's how the
Yeah,
physical
physically. Yeah.
construction is, or that's what three phase is. If you remember, in the basics of if you remember more phase stator, three phase inverter. Yeah, did you guys see these notes? Okay. See, this is a
Yeah.
single phase. Okay. In a
Mm-hmm.
single phase, if you use a single phase voltage and current, the amount of power you obtain is voltage into current. That is nothing but zero point 0.5 watts. The and it is fluctuating.
Yeah.
When okay.
Yep. AC. Yep.
Whereas if you take two phase, okay, which are 120 degrees away. Okay.
Mm-hmm.
So this is one phase and this is one phase. Okay,
Mm-hmm.
so two phases, then this will be voltage, this will be current, and the power obtained is this power. 1 watt is the power, but it's also fluctuating.
Mm-hmm.
See the
Everything
magenta
is fluctuating. Yeah.
magenta is the power
Okay.
V into I, right? See, but
Mm-hmm.
you're not getting constant power. Whereas if you take two phase with 90 degrees phase difference, earlier we have seen 120 degrees phase difference. If you take 90 degrees phase difference, you will get uh, 1 watt, 1 watt, but constant power.
Mm.
Okay. Now,
Okay.
if you increase it further to three phase, okay, you can get 1.5 watt constant power.
Okay.
So what we do is whatever AC power supply you have, we induce a phase difference of 120 degrees so that we can obtain maximum power out of it.
Mm-hmm. Mm-hmm.
Even though you do four phase, six phase and all, still the power limitations will be almost the same. There won't be
So three
much,
phase is more viable, basically.
more viable. That's why we go for three phase with 120 degrees phase difference because of constant power which provides.
Mm.
Okay. Now,
Okay.
now we know that there is a phase difference with the AC power supply. Okay.
Yeah.
So imagine this as a the circles as stator winding. Okay,
Mm.
here what's happening? The winding of this is constantly varying the number of windings.
Mm-hmm.
Okay, whereas
Mm.
here this is not the exact representation.
Sure, sure,
i'm
sure.
just i'm just
Mm.
drawing it. So the winding is varying when you provide AC power supply to this winding. Then we came to an understanding that the magnetic field is varying. Okay, now now uh, now So that say so for whenever you're doing winding, you're not that you're taking something like a rubber band, like you're doing one rubber band here, two rubber bands. You're not doing that. You're taking one piece of copper wire, and in this slot you're doing two windings, whereas in this slot you're doing three windings, in this slot
Mm-hmm.
you're doing four windings, in this slot you're doing five windings, in this you're doing more and more and more. Okay,
Mm-hmm.
how you're doing this, how the number of windings are changing depending upon this formula. If total number of windings are ns, okay, then ns by 2 sine theta is the number of windings at a given point of time. Here, if you imagine it is 10 degrees, then ns by 2 sine of 10. Okay,
Okay.
sine
Mm-hmm.
of 20, sine of 30, sine of
30. Okay.
when
Mm-hmm.
sine 90 comes, you have maximum windings at the center.
Right. Yeah. Mm-hmm.
Now you are so as I said earlier, there is only one copper wire. You're not using so many copper wires. One copper wire in this slot, you're doing one winding. So imagine the current you're providing is entering here in this slot. Now
Mm-hmm.
there is only one winding, so the the amount of total current will be less. Here there are three windings. Okay, so the amount of current is varying depending upon the number of windings. So into current, phase current.
Mm-hmm.
I'm just considering the magnitude.
Sure. Sure.
Now, okay, now what I'm saying is force, electromagnetic magnetic motive force, F is equal to B I L.
Yeah. Yeah.
Okay, and
Mm-hmm.
torque is nothing but force into radius.
Radius.
See, stator is rotor is something like this. Like when I draw it like this. Okay, but in if you take a real one, how it is like more like a uh, what do you say? The
Like a
windings are here.
cylinder.
Yeah, cylinder. Like yeah, thank you. Like a cylinder. So 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 because of that magnetic force which has been developed in the rotor, because of these windings, okay, the force exerted by that magnetic field developed in the stator on the rotor is the torque, right? That's why the
Mm-hmm.
torque is
That's right.
rotating.
Yeah.
Yeah,
Yep.
so the amount of torque which this stator is applying on the rotor for it to rotate is given by the force into r. R is the
Radius.
radius, like
Mm-hmm.
imagine a cylinder like this. Okay, this is the length
Mm-hmm.
and this is the radius.
Okay.
Okay, now the
Mm-hmm.
torque is given by F into R. So F is nothing but B I L
Okay.
to R, and this I is nothing but the current flowing into these coils. So
Right.
this I is always varying depending upon the sine theta, right?
Mm-hmm.
Here
Yes.
here the I is different, here I is different, here I
Yeah.
is different.
Exactly. Yeah.
So I'm substituting this one ns by
Mm-hmm.
2. Okay, ns by 2 sine of theta L R.
Mm-hmm.
This is at one particular position. You're not considering the complete, like
Mm.
you're only saying you're only saying at one particular position. You're not you didn't consider everything here, because always the rotor is rotating in this
Mm-hmm.
direction. Okay,
Yeah.
so you need to integrate it, and also this is
Okay.
not just one current. There are three different currents,
Difference.
like because phase A, phase B, phase C.
Mm-hmm.
So what is the phase? Like one is imagine one as a reference phase, so it is at
Mm-hmm.
0 angle. Another one is 120 degrees behind. Another one is 120 degrees after.
Positive.
Then
Yeah.
it becomes 360 degrees, right? A
Yep.
complete circle. So this theta p represents this 120. This 120. Theta p is a varying factor here. If phase A, theta p will be 0. For phase B, theta p will be 120. For phase C, it will be minus 120.
Okay. Yeah, that's why my question was like, why do you consider negative theta p instead of positive theta p? That's what my question was.
It's okay because here I'm taking whatever you can do positive theta p also for
Okay.
mathematical calculations. I thought it is more simpler,
Okay. Okay. That's
so
why.
I,
But
I
yeah, I
took
was trying to find out why is it negative theta p? Any reason?
yeah here I when I'm considering for one particular phase, then here I'll consider minus 120. Then I'll
Okay.
get this right plus 120.
Okay. Okay. Sure. Okay.
Okay.
Thank you.
So this is the total torque which is been exerted on the rotor, okay, which is being exerted on the. Now you need to integrate it from 0 to 2 pi. If you integrate it, okay, uh, I'll give you the notes. You can go through the notes which has integration. Then we will get this magnetic field ns by 2 sine of theta s minus theta r into ip cap L into R into pi. When you integrate it from 0 to 2 pi d zeta. Here, this one you need to integrate. Okay.
Sorry, Narendra. So the theta s is the
Theta
angle, yeah,
angle
stator
of the
angle, right? Magnetic field
yes,
angle.
yes,
But in
yes.
your integration term, there's no theta s.
Theta p, right? Phase difference. From the
Yeah,
phase
theta
difference,
p is just a phase difference, right?
yes,
But
theta p is a phase difference. Yes.
that is not the theta s though, right? The theta
Uh,
s is specifically
uh,
to the stator, right? I
yeah,
want to mention.
theta s is the see. Uh, So theta p is the phase, like what is the position of the phase or the phase angle, you can say. I'll show you.
For the three different
Yes, for the three different
magnetic
phases.
fluxes, right?
Yes, yes.
Magnetic fields, okay.
Yeah, I have it. I have it. I will show you. It is. It's a simple term. Okay. Uh,
Or is the term getting rearranged and you're
that
getting
the
the
terms
heat?
are getting rearranged. It's a simple derivation.
Okay, okay.
Okay.
Yeah, we don't have to go if it's already there in the notes. I can just.
Yeah, it's already there. That's why I told the major part. Okay. Yeah. I'll show you. Let's take a short break now. Okay. Now
Mhm.
the time is 4:55. We'll get back and I'll show you how it is being transferred. And from there, we'll go to vehicle dynamics. Okay.
Okay. All right.
Yeah.
Okay.
Now the
Thank you
time
very
is
much.
4:55. We'll get back by 5, guys.
Okay. All right. Thank you.
Okay.
Okay. Thanks.
Guys, are you back?
Yep, we are back.
Yeah.
Yes.
Okay. Yeah, Guna, here it is.
Okay.
Theta, theta P is nothing but theta S. Okay,
Theta P is
because
theta. Okay. Okay.
okay, theta P is theta S. Theta P is when you're considering each phase. Okay, like considering there are three different phases, but when you're doing the derivation from 0 to 2 pi, you'll change it to theta S.
Oh, okay.
That
Okay. That
that
makes
that
sense.
is defined that defines as angle of the
The
stator.
stator.
Yeah.
Yeah.
So
Okay. That makes sense.
here is this simple derivation, just a trigonometric equation. So I'm not going through. Okay, you have it in the notes, which has been uploaded. So yeah,
The final answer is like the BRL
yeah,
NS
BRL
by
NS by
2
2
pi.
by sine theta s minus theta m into IS or IP. Anything is fine.
Okay. Got it.
Okay,
Thanks, Narendra.
IS is stator current, or if you consider as IP, it is phase current. Okay, after integrating, you will only speak about stator current. You won't be speaking about phase current, because when you say phases, then you need to consider there are three phases and all. After integration, there is no need to consider that.
Okay. All right.
Okay.
Thank you.
Yeah. Yeah. Shall we go ahead?
Yeah, please.
Yeah.
Yeah. Okay. So this is the simple derivation. There is no need to remember that derivation, but remember this equation. This is important. Okay. Because once you know the equation, then only you will know field oriented control, which is happening because of this term. Okay. So BR NS by 2 sine of theta S minus theta R, IP phase current or stator current L into R into I is the torque developed in a brushless DC motor.
The
Okay.
radius is from the rotor, right? From the axis of
Which
the rotor
which
to the point where that magnetic field is applied on the rotor.
I missed the first part of your question.
So the torque is force into radius times radius, right?
No, yeah, yeah, force into radius.
So that
Force is
radius you're
okay.
basically measuring from the axis of the rotor, correct?
From the axis of the rotor to the end of the rotor.
Wherever the magnetic field is applied, or I mean, the magnetic field is basically manifest and acts on that rotor.
Can't actually say that, right? For example, like like if you imagine this is your rotor in the cylindrical shape, okay, uh, then this is the radius and
Yes,
this is length. Yeah, this is what I'm considering. I'm
got
not
it, got it.
I'm I'm not considering other things. That's just the length
The
and
coil width or anything. You're not talking about
yeah,
the
yeah, yeah.
depth
We're
of the
not
coil or anything. Okay.
no, only these are the things I'm considering.
It's a
Okay.
permanent magnet, right? So
Yeah, yeah. Rotor is a permanent magnet.
no, I'm saying that permanent magnet is affixed on the rotor, correct?
The rotor is permanent magnet is fixed on the rotor. See, uh, like
Or is it like a yeah?
for example, if you take this one, okay, if you take this one, here the rotor, the magnet is rotor, okay, in this case. See, there's a black,
Yeah, I see the shaft. Okay.
okay, here if you, there is no need of this casing, okay, if the magnet is outrunner and it is in the kind of a strip,
Got it, got it. Okay. This is
okay,
a
but whereas if you take this one, uh, whereas if you take this one, here I can't pull this out, but I can't pull this out, but in this case it is different. In this case, that the design from each manufacturer is different. In this case, I don't know if you can see
That
or
is
not.
the, yeah, I see it.
You see a steel inside that one. Can you see a steel bar ne- above
Yeah.
above
It,
above the? In this case, he is not using a strip of, instead of using a complete magnet, he's just using that small strip.
So small strip magnets, right? One, two,
Yeah,
three,
yes,
four. Oh,
yeah. There's a metal silver one which you can
right.
see. Yeah, in
Inside.
this case, in this case, the rotor is different, right? So it again changes from the manufacturer to manufacturer. So the same, both are outrunners. One is
Hmm.
using a strip of magnet, another one using a, you can say, a rod or a bar of magnet.
Continuous around, right? Yeah.
Yeah, not a continuous one. Here it's a continuous magnet, so
Right.
it varies from manufacturer. Yeah, but this is the generalized formula, Guna. So
okay,
if
got
the
it, got it.
if the construction changes, again there will be changes.
Okay,
Okay.
all right, thanks.
So so does everyone have access to MATLAB?
Yeah.
Yep.
Yeah, right.
At least I.
Okay. So from now today, we'll discuss about the forces which are acting on a vehicle and a quarter car, and from that forces, we're gonna using those force. Once we understand what are all the forces, then we're gonna build a MATLAB model for it. Now, for a simple for a simple discussion, imagine you have a road which has some small bend. Okay, imagine this is your road, and at a given point of row, at any certain point, okay, this is the center of mass. Like imagine this is the center of mass of your vehicle. Now, what happens? Like the road is at an angle. So imagine the road is at an angle of beta. This is the tangent, and your road is at an angle, at an angle of beta. You can say with respect to parallel, like, yeah, this is the tangent at that given point is making an angle of beta. Okay, this is the tangent angle. Now, now, now this is the tangent angle beta. This is x-axis. Okay, so beta is the inclination or the angle, tangential angle. Now we know there are certain forces which are acting. So as this is the center of mass, so there is a mg, gravitational force acting. If m is the mass of the vehicle, mass of the chassis, and g is the gravity, then mg is the force acting upon at this point, right? Guys, are you with me?
Yep.
Yes, right.
Yes,
So this is the
yes.
force. So what other forces can you imagine when your vehicle is moving? Okay, if it's either it is an electric vehicle or either it is a gasoline vehicle, you have one force called tractive force, FTR, with which your vehicle will start moving, and this is the force because of the motor in a vehicle. Now, when the vehicle is moving forward, there are few other forces which will be acting against the vehicle. One is aerodynamic force.
Road force.
Huh?
Friction. Friction
Yeah,
force.
yeah, friction force, or you can call it as F roll. Okay, so for okay, and also the road force which is acting in upward direction. F road. And this will be always present, so there is no need to consider much when the vehicle is moving in X direction. Right now, because of this mg, these are the couple of forces you can imagine which are very important, okay, when you consider vehicle dynamics. Now, because of this mg, there are two other forces which are acting, which are acting on the vehicle. One is fgxt, another one is fgyt. So because of this mg, there will be a force called fgy T, which is acting in this direction, and there is another force which is acting the opposite direction to the vehicle movement, and it is called FGXT. These are the most important forces you can imagine whenever vehicle is moving, or when vehicle is moving on a inclined road. Now, what is this FGXT value and FGYT value? Like FAD, FROL, they are from the formulas, okay, from the physics, but this FGXT and FGYT we need to derive. So, so mg, okay, there is an angle of there is an angle, okay, with the beta, okay. So x-axis, imagine this as your x-axis, okay. With the x-axis you have an angle of beta. I want to derive that, so let me bear with me. So to the x-axis there is a perpendicular axis which is fz by d.
Are these
Sorry.
centrifugal and centripetal concepts?
No, just the forces acting on the vehicle, not no centrifugal and centripetal forces. Because I'm not considering you are taking a turn or something like that. I'm actually considering that the vehicle is moving forward. What are all the forces acting upon it? It's not. I'm not considering that you're taking a right turn or left turn or any curvature on that. You understand?
Yeah.
Okay, just imagine like there is a small uphill on which your vehicle is moving. You're not, and imagine you are holding your steering in a straight line. You're not taking an exit turn. Okay, if you're taking an exit turn, then we should be speaking about those forces also. So, but to keep it simple, I'm only considering on a straight line there is a uphill.
It's
Okay.
climbing a mountain like a hill or something like that, right?
Yeah,
A
hill,
ramp
which
or
is,
something.
yeah, a ramp or something with an angle, and when you draw a tangential, then it has an angle of beta. Okay,
Yeah.
okay. Now this is mg. Mg is acting downwards, and in the same time, if you draw to the opposite side, okay, it also becomes, you can say it as minus mg, right, in the up here this direction. So to derive what is FGYT, okay, I'm gonna draw mg in the direction, or mg here. I'm just changing the orientation a little bit. I didn't change much. See, this is the x-axis. To the x-axis perpendicularly, I have FZYT. X-axis, I see FZYT. To the FZYT, okay, I have mg. Okay, here, this is the mg. Okay, sorry with me, or maybe it is confusing. Let me draw one more time. See, take a road with a small inclination of beta, not with a very big inclination. At this point, okay, if you draw a tangent, okay, if you draw a tangent, then imagine this is making an angle beta. Okay, if your vehicle is at this point, then what will happen? It will have a m into z is the gravitational force. Now, if your vehicle is moving in the forward direction, okay, in the forward x direction, then there will be a force acting on it. It is called, because of the engine, which is called tractive force, FTR. Okay, now if the vehicle is moving forward, then definitely there will be aerodynamic drag, AD, right? For example, if you like, why Tesla, if you take Tesla, Tesla did very good research, and the Tesla trucks have very less aerodynamic drag, because the front curvature is designed in such a way that the air can escape very easily in drag of very almost zero point 0.1 is the aerodynamic drag. For example, if you take magnetic levitation trains, you see the curve right at the engine. So the same thing, the same aerodynamic drag I'm speaking about. So what happens? The air will be acting against the direction of the movement of the vehicle. So it is in opposite direction, and it is called FAD, aerodynamic drag. Now, now aerodynamic drag, and there is also a friction. Okay, vehicle is moving against the friction, and it is called F roll. Another important force which are acting against the vehicle is because of this mg. Okay, if it is called FGST. Okay, this mg we need to resolute into two parts. One is FGYT, another one is FGXT. These are the forces in general which are acting on your vehicle whenever you're moving forward with the force F.
So
Okay.
what is that FXT and FYT? Is it some axis that you are defining so that you can resolve the forces?
No, 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 no. Same uh, like this is mg, right? Because of this force mg, there will be two resolute forces which are called FGXT and FGYT acting upon the vehicle.
You're resolving the mg into
Yeah, into two
two.
parts, two
Yeah.
parts,
Okay.
FGXT and FGYT. So
Okay.
FGXT will be mg cos of beta, and FGYT will be mg sin of beta. Okay, these are the forces which are acting upon the vehicle. Wait, okay, acting upon the vehicle. If you take just for consideration, this is sine, this is cos. Sorry, I'll derive them also just to show you. Okay, this is sine and this is cos. So later I will derive them and I will show you how it is mg sine beta, mg cos beta. But for now, just understand the major forces which are acting upon the vehicle. Okay, now if you take these forces into consideration in a quarter car. Okay, I'm not taking a complete car. Imagine I have a quarter car, because if you take a complete car, then there are many other forces. Okay, guys, are you with me? See, this is the best derivations we can do. It is
Mhm.
physics, right? So
Yeah.
we can't actually experiment, and I can't show you. Oh, that's why I have FAD. That's why I have F roll. Okay, these are just forces. You need to know that. Oh, yes, they are acting on the vehicle. That's it. More like
So,
a definition.
so
Okay.
Narendra, so you're drawing
Uh-huh.
half the car. So are you
Quarter,
saying that the
quarter.
other side of the car is not there? You're just
No, quarter car. Because if I consider full car, then I need to consider row, pitch, and yeah, it becomes really difficult to resolute those. So what I'm doing is I'm only taking 1/4 of a car, and I'm just trying to understand what are the forces acting upon the wheel and also on the chassis.
it seems to be like half of the car, pretty much. You're trying from the B pillar all
There
the
is
way to
only
the
one.
bumper, right? So
There is
are you're probably uh, you know showing
no.
only 1% through
Yeah.
the paper,
Yeah,
right?
yeah.
Quarter pounder, yeah.
Okay, this is just a quarter car. Okay,
Okay.
one
Got it.
fourth of a car, so Q car. Now we know in general these are the forces acting upon it. Apart from these forces, there is two other forces which are acting when you take a real vehicle. What are the uh, reactive force between the wheel and the chassis? FRR. It is called FRR. Reactive reactive force. Okay, force between chassis and wheel. That is one force. Okay. Then another force is viscous force. Viscous force. So I don't have any definition right now. You can say it is given by viscous friction into VXT, or the movement. If the vehicle is moving in X direction, VXT will be the velocity in X direction. Okay, so this is viscous force. These are two other forces. Now let's combine all these forces to understand what are the forces will be cancelled out and what are the forces will be staying with the vehicle. So for example, let's separate these chassis and wheel into two different parts. Okay, now let's take chassis. So in the chassis, you have engine. Okay, because as the engine moves, the torque will be developed, and once the torque is developed, the wheel rotates. If the wheel is rotating, the vehicle will be moving forward. So the force with which the vehicle moves forward, it is called FTR. So so uh, so vehicle is moving with the help of a force called FTR, tractive force. Guys, are you with me or is it really boring?
No,
Okay.
Got it.
Or
follow.
okay. These are more like a definitions. Okay, they say there is a force acting upon it. I can only say that I don't know. See, so they are more like a definitions. If you uh, if you want, we can jump to the MATLAB, and as we built, I can explain. But is only shall I continue?
Yeah,
Yep.
continue, right. Just the theory first quickly, and then we'll go into practice. Yeah, that's
Oh,
good.
thank you. So the tractive force is pulling the vehicle. Now, if the tractive force is pulling the vehicle, these forces which are acting against the vehicle. So what are they? FAD, FAD, which is uh, aerodynamic force.
Aerodynamic, yeah.
Okay, and also F roll, frictional force. Okay, and what is the other one? FG, XT.
Mhm.
Okay, these are the forces which are acting against. Now imagine there is a trailer connected to your vehicle. Then there is a force because of that trailer connected. Okay, okay, and also there is viscous force acting against the vehicle. Now, now if you take a conclusion, or if you take with what speed the vehicle is moving, then the force which is moving the vehicle, FTR, minus FAD, okay, minus F roll, okay, minus FGXT, okay,
Sorry, what is the last one?
FGXT, this one,
What is that force?
because of that because of the mg, gravitational force,
Oh, okay,
Hmm.
got it. Because
okay,
it's an angle, right? Okay, there'll be a negative force.
yeah, there will be an angle, okay,
Okay.
FGXT, and also the rolling force, F roll I already wrote, minus viscous force,
This one is what?
okay.
What's the viscous? Where's it coming from?
It is because of the contact between the wheel, or you can say, yeah. So even though you consider aerodynamic force, okay, the air between the here, if you imagine, yeah, this one here,
Oh, this is the. It's like back aerodynamic
uh,
Airflow. Air,
yeah,
airflow. Air.
airflow.
oh
But
yeah,
you have
yeah, because No, aerodynamic force is acting on here on the
Ah,
chassis. Okay,
yep.
and this one which is escaping. So with that we get some force called viscous force, which will be also acting against the vehicle. Now, what
Mm.
happen when will this vehicle will move? When when FTR, okay, with which your the amount of force you're generating because of gasoline engine or a motor should overcome all these forces, right? Then only your
Mhm.
vehicle will move. And suppose if your vehicle is moving after overcoming all these forces, then it is given by F is equal to ma. So mass of the chassis into acceleration dv by dt. Okay, guys, are you with me? So
Yep.
so what I meant is whatever force you are building, okay, whatever force you are generating, okay, because of the drive system, okay, it should be much higher and it need to overcome all these forces. Then only then only you can make your vehicle move. Okay. Now FEAD FTR minus FEAD. Okay. Uh, rolling force we can eliminate because the wheel okay now few forces we can eliminate because I'm only considering the chassis, I'm not considering the wheel. So rolling force can be eliminated here when it comes to quarter car because the I'm only considering the chassis. I didn't consider the wheelet. Okay, minus FGXT is because of the magnet. What do you say? Because of the gravity minus viscous force, and I forgot another force that is F trailer. Okay, trailer force. Okay, now let's go to
Sorry,
the
what
wheel.
what is the trailer force?
Like if there is a trailer attached, just I'm considering for now. If there is no
Right.
trailer, then you can neglect that.
Okay.
Okay. Okay. Now let's take the wheel. On the wheel there are again two kinds of forces. One is torque, another one is force acting upon the vehicle, force acting upon the wheel because the wheel is moving. Do you agree? That's a force and there is a torque. So we resolve it into two different terms. Now if you consider any wheel on a road, what will happen is the point of contact is not it, it is not just a point. It is like a surface, right? And
Mhm.
Mhm.
and mostly
Yes.
mostly if you take the center of the wheel, okay, the center of the wheel will not be touching. It will be quite away from the center of the wheel. If you observe very slowly, let's imagine that distance from the center of the wheel to the point of contact of the wheel to the road as d. What I'm doing is this is
Yeah,
the
yeah.
center
Yes.
of the vehicle. Okay, in practical cases what happens, the center of the wheel doesn't always touch the road. Okay, it will be little bit flattened, and the point of contact of the road to the of the tire to the road is somewhere little bit away. That distance from the center to the point of contact on the road, I'm considering it as d. Okay.
Mhm.
Now 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 the engine is developing the uh, torque, and the torque is provided to the wheel by using the shaft. So there is a track to torque. Okay, track to torque with which your wheel is moving, TTR. Same, this track to force with which your vehicle is moving forward, or okay, this FTR is because of this TTR. The TTR is acting on the wheel because of which the wheel is moving, right?
Mhm.
Okay. Now again there are few forces which are acting upon the which are acting against this also. Okay, one is FRW. reactive force. Okay, reactive force between uh, reactive force between chassis and the wheel. So it here it is acting. Okay, here it is acting against the uh, wheel movement. So in the same way, when you consider the uh, when you consider the chassis, it will also act. It will be acting on the opposite direction because it is reactive force between chassis and the wheel. Like when you two points are in contact, okay, if I'm trying to push, okay, there will be force acting on one body. At the point of contact there are two forces. One is acting in the direction of one body, another one is acting in the direction of the other body. So the same thing happens here because you brought in contact two different objects. One is wheel, and on top of that you placed your quarter car. So there is a reactive force FRW, and also at the point of contact there will be a frictional force which we call it as F roll. Frictional force which we call it as F roll. Now, on this wheel also, because of the mass of the wheel, there is something called FGYT acting upon the wheel. These are the forces which will be acting on your wheel when you consider a wheel in general. Okay, now let's let's write down the equations for the forces and for the torque developed in the wheel. Now, if you take, okay, uh, F R R reactive force plus F roll, guys, are you with me?
Yep.
Yeah, yeah.
Yes.
Plus
Yes. Yep.
M wheel into dv by dt equal to 0. Do you guys agree? What did I do?
So you're bringing the
Forces together, only the forces.
so what
Because
is it
why
negative?
I yeah, mechanical forces, just
So
I'm
it
not
is so the
yeah, please.
um, so the you have the mass of the wheel times the velocity of the
Acceleration,
wheel, right?
yes, times the
So in
acceleration.
Yep.
the other equation you had it as a positive term on the right side of the equation. Here you are having it on the left side of the equation.
Yes, yeah,
Is still
yeah,
positive or negative?
it is still positive because here so in this case, for example, in this case, uh you are I see here there is a force acting upon the chassis, and because of that it is moving. But on a wheel, you're not acting force, the torque is acting on the wheel.
Hmm.
So I'm only considering the forces which are acting on the wheel. Because
Okay,
of
okay,
the
got it. Yeah.
torque, because of the torque, this is developed, but I'm not considering the torque. Here,
Okay,
this is only the addition of forces which are acting on the wheel.
got it,
If I,
got it.
okay, I'll write down another equation for the torque. Okay, so I want to rewrite this as FRW minus F roll is equal to MW into dV by dt. Are you guys with me?
Yep. What
Okay,
about
Yes.
your FGYT?
okay. I've
The
FGYT. See, here the wheel is FGYT is acting in upward direction,
right.
whereas I'm considering the forces which are in a linear direction,
Okay.
horizontal direction. I'm not considering it in this equation.
Okay.
Okay. Now and also now let's write down the torque. QUE. Sorry. Now what are the torques acting? So this is one torque which is making the vehicle to move, main tractive torque. So TTR, right? Minus minus. See, this is the torque which is acting in opposite direction because of FGYT. This torque is moving in this clockwise direction, and this torque is moving in opposite direction, right?
Yes.
So
Yes.
minus
Yeah.
FGYT into D, or if you take it as B, because I don't want it to complicate with viscous force. So I'll be naming it as B. So this will be B. Okay. My okay. Now F roll. See, this F roll is of the frictional force. So it will also help. It will also develop some torque because of this friction. There is a force, and also the radius of the wheel will also see. You're pulling it, right? So there will be a torque because of this F roll. So plus F roll into radius of the wheel is equal to the inertia of the wheel into angular acceleration of the wheel. Guys, I'm not considering very minute forces. I'm only considering some simple forces which are acting on the wheel and some simple torques which are acting on the wheel. Okay, and whenever you consider, and I'm only considering a quarter car to make to keep it simple. Now Now the forces acting are acting because two bodies you are bringing together. One is wheel and the chassis. So if
So,
as I brought,
so 1 second,
okay,
Narendra. So in this
yes,
equation,
uh-huh,
you put all the moments and equate it to the torque
equate
on
it
the
to everything is torque, right?
yeah,
Force
yeah. So
into
equated
radius,
to
force into
yeah.
radius, and here also it is
So your polar moment of inertia times the angular acceleration. That's what you put there, right?
yeah, inertia into angular acceleration.
Okay, okay, got it.
Okay, now now divide now so what we did here, we considered here we considered the track to torque. Okay, so so the vehicle, okay, or imagine there is an engine. The engine is trying to move the wheel. Okay, so the wheel is rotating, the, and on top of the wheel you have the chassis. Okay, so the chassis by itself doesn't have uh, you're not pushing, right? You're not pushing or pulling the chassis. As the wheel rotates, the chassis is moving, right? Guys, are you with me? It's not that I am pushing my chassis and also the wheel is rotating. No, there are not two things happening. There's only one thing happening, that is the wheel is rotating. As the wheel is rotating, the chassis is moving. So when you consider something like this, where you only consider that the force is only exerted or the torque is only exerted on the wheel, not on the chassis, then you need to rewrite this equation a little bit more, because earlier we consider FTR and here we consider TTR. So there are no, if you consider TTR, then you shouldn't be considering, if you consider FTR, then you shouldn't be considering TTR,
Yeah. Right.
because there is only one force acting, that is either torque or force on the chassis.
Right.
So let's rewrite this equation now, because we considered this TTR torque. Now, if you want to rewrite, let's rewrite this one little bit to make it okay. Now let's rewrite this one. Now there is no tractive force because nobody is pushing. Yes, nobody is pushing. But there is reactive force. because you are bringing two bodies together. So there is reactive force FRW. I considered FRW here in the left hand side direction. So for the chassis, I need to consider in right hand side direction. Equivalent and opposite reactive force, it is called. So FRW minus FAD minus FGXT, okay, minus F trailer, trailer, sorry, trailer, okay, minus viscous force, viscous force is equal to your chassis is moving even though you're not pushing it. So M into dV by dt. These are the forces acting on your chassis. Okay, so now these three forces these three equations we need to simplify in order to find the final equation. Okay, now here this torque I can convert it into force. How? By dividing it by RWH. So TTR by RWH minus FGYTB by RWH plus F roll is equal to JW by RWH into DWH by DT. Now everything is in
Just
forces.
dividing
One,
by the radius of the wheel, right?
yes, dividing with
Okay.
radius of the wheel. One, two, three. Okay,
Mhm.
these are the three forces. Now let's combine these and let us see what are the resultant one. So F roll and F roll will get cancelled. F roll, their force here and there's torque here, and the torque is converted into force. F roll is getting cancelled. FRW and FRW got cancelled. Guys, are you with me?
Mm-hmm.
Okay,
Yes.
FRW, F roll get cancelled. Now bring remaining terms together. So this torque is converted into force. So you can write it as TTR by RWH minus FGYT into B by RWH. Okay, these two got cancelled. And here FAD, FGXT, F trailer, and viscous force. 1, 2, 3, 4 forces. Okay, minus FAD. Okay, minus FGXT. Okay, minus F trailer. TRAILER trailer minus viscous force. 4 forces. Okay, is equal to here M into dV by dt. Here MW into dV by dt. Here JW, okay, M into dV by dt plus MW into dV by dt plus JW by RH into dW by dt. Okay, so this is the equation for the forces acting upon a water car, not on the complete car, only on the quarter car. Okay, now what we will do is we will develop a MATLAB program for this, and we will give a I'll show you how to develop MATLAB program for it, and we will develop a road profile, and then we'll build a. I'll show you, and you push the acceleration uh, after overcoming all these forces, how your vehicle is moving. Okay, this is the equation in the simplest form possible. You can simplify it further if you want. Okay, if not, you can leave it here. Okay, shall we go? Shall I go ahead?
Yeah.
Yep. Yeah.
Yeah. Okay,
Yeah.
guys, please open MATLAB
Okay.
and go to Simulink. Home, Simulink. Okay, just a second. I want to see what you
Not
have.
SimSpace, right? Just Simulink.
Yeah, Simulink and Simscape workspace is the same, so there is no need to worry. Okay, download this vehicle dynamics. See vehicle dynamics quarter car. Uh, are, are you guys with me? Hello.
Yep.
Yeah.
Yeah,
Okay, the
we're downloading that. Yeah.
quarter car notes. Go to this one. Quarter car
Vehicle
notes.
dynamics, right? Inside the vehicle
Yeah,
dynamics.
yeah,
Vehicle
vehicle
dynamics.
dynamics and also quarter car notes.
Yeah, I'm
So,
in there. So that's a just a Word document, quarter car plus powertrain
yeah,
name.
yeah.
Open that.
Uh, oh, this one only, just this one only quarter car notes.
Yeah, yeah. So that's a folder.
Yeah, that's a folder. Yeah, you're right.
So you open that, there is a Word file.
Yeah, Word file. Okay, here is the Word file. So here the details of each force is given, and okay, the modeling is very simple. So as I said earlier, our goal is to make you make you familiar with MATLAB at the same time familiar with electric and hybrid drive system. Okay, drive system mainly. That means motors and all. So here, this is the equation which we just implemented. FTR is the tractive force, which is nothing but here. TTR by RWH is nothing but FTR minus FGYT. Yeah, FGYT B by RWH. Okay, minus FAD, FGXT, FRR is the trailer, minus DVXT is viscous force. So these are the forces. After overcoming all the forces, this equation is rewritten. Just this equation is rewritten here, dWH by dt, right? Uh, so this can be rewritten in terms of uh, velocity. Okay, so just a second, I forgot the term. Okay, DWH. Mm. Just I need to remind, just I need to check with that, but this is the same equation, guys. The equations are the same. You can compare. Now our aim is to build this model. Okay, here, uh, if you can see here, This is the tractive force. Tractive force is from any kind of drive system. It can be either vehicle, it can be either electric motor, or it can be either a gasoline engine. So the tractive force you are receiving, you're providing it to the equations. Then from the V wind, you will be finding uh, FAD. Okay, so and all you'll be finding FAD. So if you make V wind 0, FAD will be 0. Then what we get output is a acceleration. If you if you uh, integrate acceleration, you'll get velocity. If you integrate further, you'll get distance. Okay, this is the road profile which you are giving right now. Now let's see, once you have the block diagram, okay, how to build the MATLAB Simulink for that. Okay, that is very, very important. Now, okay, guys, can you follow me? So do it.
Which file you are in? Oh,
Uh,
this 21?
yeah,
Oh,
here, this one, water car notes.
oh, I downloaded the one below. Okay.
Okay. That one also we'll go through. It's more
Oh, okay.
complicated one. I
Uh,
will, after going through this, I'll tell you
okay.
where different drive systems are also included in this Simulink. Okay, once you understand how the Simulink is built, it acts as an exercise, then we can go there. Okay, hello.
Okay, yeah.
Okay, so you guys already did basics of MATLAB. So what is your first strategy? Can someone answer, or can someone say something? What will be your strategy in order to build something with equations and integrations and some complicated equations? What will be your strategy in MATLAB, guys? What, like if you think it like somebody gave you this one, I gave you a homework. Okay, do this one. So what you will do? What is your first thing? What is your first thinking on how to build this one?
So we're
Uh,
using the symbolics, right?
yeah,
Or
Like
the
in
use it.
inputs.
Yeah, see. So two
Simulink,
things.
right?
Yeah, you in the Simulink you have inbuilt blocks. Okay, so as engineers, because Simulink is very easy, we always think of using Simulink blocks, but but for a complicated equations, never go with Simulink blocks. Always go with MATLAB function. MATLAB
Okay.
function. MATLAB function is very easy compared to Simulink, because here there is no need to bring hundreds of blocks. All you need to do is write down the equations and then use them as you want. Whereas in the symbolic blocks, there you need a block for this, you need a block for this, you need a block for this, which is very irritating and which is not practically possible, and it takes so much time also using the symbolic blocks. Okay, symbolic law blocks more for hill people, but for engineers, like I mean, other than the hill, like if you want to build something, it's always better to go with MATLAB function. So, uh, okay,
So
yeah,
there's
bring
two
Mat.
MATLAB function, Narendra. So that MATLAB function in a Simulink, MATLAB function
Oh,
in a HDL,
oh,
then
only
there's
Simulink.
also only Simulink. Okay.
Yeah, only Simulink. Yeah, both are the same.
Mhm.
Okay.
Okay. So MATLAB
So it's a
function, open it, and now see here this is the one I want to build it. Okay, guys, this is the equation I want to build it. So what is the output here? Dvx by dt. So the output of the function is given by y. So y is nothing but dvx dt.
sorry. What is it? dvx by dt?
Dvx, see, output is, see, output of of the vehicle is nothing but velocity, right, or
Right.
Oh,
acceleration. So here this equation is rewritten. This equation here dvx is taken out, okay, and it is rewritten in this form.
No, I get it, but for instead of y, you just put
Yeah,
dx by dt.
y is the output
So
of this function, right?
okay,
Okay, so
y.
for my block, my output is nothing but acceleration. So I went inside and the function, like if you go here, this is how it is looking like when you open it. But my output is nothing. I want to rename them. I don't want to keep it as y, then I'll get confused. So I'll
Here's the
say
name.
dvx dt.
Replace the y by dvx dt.
Yes, replace the y by dvx dt. Yeah, you are right. Okay, now you need to type what is dvx by dt. So here you have an equation for what is dvx by dt. So let's write it down. Dvx by dt, go to the last, equal to 1 divided by, so divided by km into m. Okay, km divided by m. Okay, into f t r minus,
So you're putting the capital K and lowercase m for subscript.
yeah, subscript. Yeah, the way you feel
Okay.
like it's okay.
Oh, is that right? Okay.
Yeah, I mean, if you're comfortable with whatever way you feel like, okay, you can do.
Okay.
Okay. Km into m minus into ftr minus fty t into p by r
Narendra, I'm
w.
at one step back. If you don't mind, can you help me how to write that function there in this space, generic window?
Okay, you can share your screen, guys. Remaining guys, write this equation in the MATLAB, the first equation. Yeah, please share your screen.
I am doing that. So here, how can I? So I already put it on the screen.
Okay, here, what do you want? Okay, search for MATLAB function. MATLAB, yeah, MATLAB function.
Second one,
Yes,
right?
yeah, second one.
Okay.
Okay, open it. Double click it, then it will open.
Okay. Yep.
Okay, there in replace y with dvx by dt.
Like this.
Yes, that's it. Yeah, you are there. Okay,
And okay. Yeah, I will follow you.
okay, okay. Okay, please stop sharing. Okay, guys, are you with me? Are you, did you write this equation? FGYT into B by RWH minus FAD, okay, minus FEXT, okay, FGYTT capital. Just make sure you use same nomen, minus FRR minus D into EXT. Okay, guys, did you write it?
You're not that fast.
I'm only typing whatever I have. So you have the notes, just don't need to follow, just type it.
So those capital letters are important.
No, as long as you remember what you write, it is completely fine. This is my basic, my way of writing the things. Okay,
Okay,
there is
yeah,
no
it's a good
need to.
idea actually in programming. Yeah,
Okay, shall I go ahead?
just a sec. Just
What
copying
about,
yours.
yeah? What about
You,
others?
you don't
Mariana,
have a
are you?
semicolon there? Do you need to have a semicolon or no?
Yeah, and yes, just it's always good to have a semicolon. Guys, what about others? I know a few guys who are talking. They are interactive. Mariana, are you doing it?
Yes, I have finished the
Okay.
question.
Any questions?
No, only the first one.
Yeah. Mario, what about you? Mario, Alessandro.
Yes, yes, it's okay for me.
It's okay for. Where are you? I mean, you're joining from Italy,
Yes, I'm from Italy.
Turin.
Sorry?
From Turin or Milan? I'm just
Ah,
asking.
no, no, Modena. Modena.
Oh, oh, Modena. Okay, nice. Ayub, what about you?
The same.
I work with Maserati.
Oh, okay, nice. Okay, good to know. Thank you. Ayub, what about you?
It's okay. I'm from Morocco.
Oh, nice. Okay, you're able to follow. Any questions for me? I can increase
Uh,
this font style, font size if you, in case. Yeah, let me increase this font size. Yeah, Ayub, any questions for me? Like, are you
no, it's
okay with it?
clear.
It's clear.
Yeah.
Please, I mean, I can't ask everyone, so if you have any questions, please let me know. Let me increase the font size.
Yeah, those guys in Italy and Morocco is after midnight, right? As-
Oh,
Yes,
Farid,
yeah,
the time is very hard for me, but
very hard.
Yeah.
Yeah,
Farid,
I
what
don't know
about
how
you?
They are 6 hours ahead of us, right,
Yeah.
Mario?
and for me it's 2 minutes past midnight.
Okay.
Wow,
Yeah.
you're very
Mhm.
dedicated, Mario.
Yes.
Yes.
Okay. Uh, Farid, what about you? Are you able to follow?
Yeah, I'm okay. Thank you.
Okay. Okay, guys, please, if I'm confused, if there is any confusion, or if you are stuck at any point of time, please let me know. So I'll make it clear. And but everyone, I want everyone to do this exercise so that you'll get hands-on experience on MATLAB. That's also main motto of this class. Okay. Now, now we wrote this final equation. Okay, write it at the bottom, not at the top. Okay, please remember that. Now now we don't know these terms. What is Km? What is M? FTR, FGYT, B, BRWH, all these terms. So we need to define those terms in this space. Okay. The first term is Km. So what is Km? On the Word document, if you scroll up, okay, you can find what is Km. Km is equal to 1 plus MW by M plus JW by MRWH square. This is the term. How did they got it? They minimized this term and they replaced with Km. It is very simple what they did. It's nothing but velocity is equal to, okay, velocity of the vehicle is equal to radius of the wheel, okay, RWH into angular speed. Okay, now dv by dt is equal to RWH into dWH by dt. So dWH by dt is nothing but 1 by RWH into dV by dt. Now here in place of this term, I'll be substituting this equation. So then I'll get M into, okay, dV by dt plus MW into dV by dt plus JW by RWH square into dv by dt. Guys, are you with me? Now, if you take common, if you take terms common, okay, it will be m plus mw plus jw by rwh square into dv by dt. Further, they took the m also common, because here if you see in the equations, it is see mw by m. So they took m also common here, which is 1 plus mw by m plus jw by rwh square into m, okay, into m into dv by dt. Okay, this whole term they replaced it into am into m to dv by dt. That's how they got dv by dt is equal to 1 by km into something. Here, if you take this term, now this one can be, this whole term can be replaced, right? Is equal to km into m to dv by dt. So what is dv by dt?
Acceleration.
Sorry, that's a force, right? M into dv by
Change in
dt.
velocity.
Yeah.
Yeah, gv
So
by
this,
dt is change in velocity.
okay, see here, this is the equation. Okay, this is the equation. Now they took this term to the other side. That's it. If you take this term to the other side, 1 by am into m, and this will go away. See, this is the equation they have in the notes. See, dv by dt is equal to 1 by km into m. Okay, ttr by rwh is ftr minus c. Okay, that's
Mhm.
how they got it. The simple derivation they did is, I mean, I'm not doing every derivation because it takes too much time. But here, V is
Right.
equal to RWH into omega H. From there, they got this term. They simplified it. Now, Km is nothing but these three terms. This is Km. Okay, so now you need to write down what Km is. Okay, so copy this one. Always copy the variable. Don't type it again. So Km is equal to, in the Word document, you have the equation for Km. So no need to go to the derivation here here you can find in 2.29. Km is equal to 1 plus, okay, mw, okay, mw by mw by m, okay, okay, plus jw by m into rwh square. Okay,
By some reason, when I copy and paste, it is not working on my screen. I'm not sure if the same thing with everyone.
it won't copy. You need to type it.
Yeah,
But
it's not easy. Yeah.
you just mentioned that we don't type it, we need to copy.
Oh, you need to copy this. Oh, you're using online, so it won't work.
Yeah,
Sorry.
it's
All,
fishy. Yeah.
yeah, online work. Online, sorry, I'm online. MATLAB has some limitations.
Okay, what needs to
Okay,
be done now?
now just
Just
make
write it
sure
down.
you use the same.
Same thing. Okay,
Yeah,
I will.
okay, so now you have that. Here also there are many unknown terms which you need to define. Okay, what are they? So MW, M, all those values, you can find it in the notes. See here, what is M? M is equal to, okay, 350 kgs. Okay, kgs. Okay, MW is equal to, Okay, 15 kgs wheel weight. Okay, next. Then what do you have? JW. So JW is equal to, so before that you need to define RWH. RWH is equal to 0.2. Okay, wheel radius. Wheel radius in meters. Okay, now you can define JW. So J capital W is equal to 0.5 into MW into RWH, okay, to the power 2. Okay, I have every term here. So I'm done with AM and M. I defined what are the values. You can't leave any values undefined. Okay, then MATLAB will throw you an error. Okay, so the next term is FTR. FTR.
Sorry, one question. So
Okay,
some of the things are highlighted in yellow. For example, that function of
you,
U, right?
because
So what
I
does that
did
U mean?
be, see
What's the
basically
meaning of the highlighted by
see,
yellow
see,
means?
see here you have drawn a MATLAB function, right? Okay, so here if you see the name of this block is still function. Okay,
Okay,
now this function has inputs and outputs. Output you defined it as dvx by dt, and you defined what is dvx by dt.
okay,
Okay, and you didn't define what are the inputs. That's why it is showing in U. Okay, now if you go to the main block diagram, what are the inputs to this block? FTR, vwind, beta, and vxt are the inputs. If you look at the Word document, you'll understand that these are the inputs: vwind, beta, vxt, and ftr. So you need to define what are the inputs in the place of u. Okay, so what are the inputs? Ftr, capital T, small r. Okay, whatever notation you used in the here, you need to use the same one. Okay, ftr. Okay, then uh, vwind. Vwind is another input. Another input is beta. Another one is vxt. Okay, 1, 2, 3, 4. Yeah, I defined all the 4 inputs. Now again these are in yellow because you didn't use them at their left ideal. That's why it is showing as you didn't use in the equation, Narendra. You need to use them. What is the purpose of bringing that inputs into the function if you're not using them? That's what MATLAB is asking you.
the FTR is not defined, vwind is not defined.
FTR
Okay.
is not FTR is an input, so there is no need to define. But I used it. That's why it is in it has white background. Vwind is an input, but I didn't use it in the equation at or in the program in the algorithm at. That's why it is showing in yellow. VXT I used it here. That's why it is in normal. It's in normal way. Okay. Now
Okay.
now FTR I'm getting it. I defined it. Now FGYT is the one which is remaining. So FGYT, go back, look for FGYT in the Word document. So here in the Word document, I have all the forces. So FGY, oh, this is FGXT. Okay,
Yes.
FGYT. This is M plus MW into G into cos beta. Okay, FGYT, capital T. You should use same notation as you used here. Remember that, otherwise it will throw you an error. FGYT is equal to M plus MW, okay, into G. You didn't define G yet. Remember that, sine of theta. Okay. Now you
FGYT, right? So it's cos
yeah
of beta.
FGYT. Yes, thank you. Cos of beta. So G is equal to 9.8. Okay. Now you have FGYT. Now you don't have B and RWH you already defined. Now you need to define B. Okay. B is the distance. See, B is rolling center displacement and which is given by 0.01. So define B. B equal to 0.01. Okay. Okay. Gravity is 9.81. Okay. This is done. So B RWH is done. Now FAD. So what is FAD? FAD is this one. This is not sine. This is like there are two, right? Two things. Okay. This is sine of angle, SAGN. Okay. Or sine. Sorry. This is so you know the difference between these two, right? So this is sine from the tangent, like tan, cos, sine, cosec
Mhm.
from there. And this is just sine, whether it is plus or minus. Okay. The MATLAB function for this is sine. For this one is SGN. MATLAB functions.
Okay. Okay.
Okay. So here you're using SGN. Okay. So FAD AD is equal to SGN. Did I forgot or what? Uh, what the name of the function? Just give me a second. SGN. Sign off.
It's SEGN.
SE.
EGN.
No, no.
Yeah, it's
SG.
between okay, it's between S and G. You need E. Oh,
Oh, I don't think that's the right one. Just no, I don't think that is the one. Oh, SIGN. Yeah, it
yeah,
is
yeah.
SIGN. Yeah. How did I find? I found from the MATLAB help. SIGN.
Oh,
Yeah, see here. Here. In the MATLAB help. Okay, search. See, here I find SIGN. Then see here.
mm,
You can
okay.
say, yeah, yeah, one. See it. One if the corresponding element X is greater than X, greater than 0. Okay, so here if you go inside, it will give you two details. SIGN. Okay, here sine of 2 is 1. Okay, whereas if you take sine of -2, it will be -1. Okay, so you
Mhm.
need SIGN sine. Okay, sine of V. V is nothing but VXT velocity. So velocity, okay, into, guys, please do it along with me. This is an important exercise for you to understand how MATLAB works. Okay, and rho is the, okay, rho into CD into AF. See, this is the equation. Okay, RHO. Typed it somewhere. Yeah, this is the equation FAD. Okay, rho RHO into CD into AF AF into V plus V wind. So VXT plus V wind. Okay, 2 power 2. Okay, so this is the equation for, Okay, FAD. Here you have VXT, you have 0.5, you don't have row. So go here, row is 1.2754. So define that 0.2754. Okay, this is good. CD is 0.2. CD equal to 0.2. Okay, this is drag coefficient. CD is drag coefficient. Okay, CD is 0.2. AF, you need AF. So AF equal to 0.1. AF equal to 0.1. Okay, VXT you have, V wind you're getting as input. Okay, this is done. Okay, you have all the equations, FAD. Then you have FGXT. FGXT is mg into sine beta. Okay, FGXT, mg into sine beta. FGXT is equal to m, okay, into g into sine beta. Okay, FG beta. Then what is a, okay, FRR. Okay, you need FRR. FRR. Okay, trail force. Trailing force depends on the quarter car is pulling. You can make FRR 0. FRR. Imagine there is no trailer attached. Okay, and D. Need D, viscous coefficient. Okay, D is, okay, where is D? Okay, rolling under displacement. Or okay, for now we can make D also equal to 0. Don't worry. Okay, D also equal to 0.
So for
Okay.
some equation, I have the equal to is highlighted in yellow.
Maybe you didn't give the
Semicolon. Okay,
semicolon.
got it.
Okay, guys,
Okay.
you need to define every term here. Please finish it. We'll go to the next step.
Okay, so I have one more thing that dv dvx dt
Okay,
it
deviate.
is underlined by a light red dotted line.
Oh, because maybe these two terms are conflicting. Right? Make sure you have same, like
Full name.
same notation.
Oh, okay, got it. XT. So now it's gone. I was missing the X. Okay, good, thank you.
Okay, guys. Ayub, are you good? Shall I go ahead?
Yeah.
Yes.
Yeah.
Okay.
Narendra, just 1 second. For me, the
Yes.
FGXT is showing still as yellow.
This one,
Yes.
FGXT, still as yellow.
Yes.
So make sure this FGXT and this FGXT are the same. Like they look the same with the same notation. First step is that this one and this semicolon at the end.
I hope you are seeing my screen.
Okay, okay. FGXC. There the T is capital. In line 17, the T is small letter.
Thank you. Thank you.
Yes. Yeah. Okay, guys. Okay, let's go ahead. Okay. Now we did this block. We did this block. Now let's do the remaining blocks. Now the other block is beta. Okay, let's do the simple ones. We'll do now 1 by s, 1 by s. You need two integrators. Okay, here. So
How do you go pick the workspace, Narendra, from the browser?
up arrow.
Up arrow.
How do you go to the workspace?
Oh
That's
yeah,
what
up
you
arrow.
asked.
Yeah, got it. Okay. Got
Okay,
it.
and there are two integrators here, guys. See, can you see? So integrator. Okay. Uh, so acceleration, you integrate it, you get velocity, and you integrate it again, then you get distance. So this velocity, you need to provide it as an input to your function. So drag it and attach it. Are you with me? Hello?
Yep.
So you have two integrators? Okay.
Yeah, I have two derivatives. And FTR is the tractive force, right? Which you need to provide. So get a constant, okay, and get a gain block and attach it to the tractive force. Everyone, did you guys finish it? Please.
Yep.
I can wait if you have truckly you finished. Tofik, did you
Yep.
finish?
Yep.
The last step is what integrator or
Yeah,
actually gain?
yeah,
No,
integrator and the gain.
okay, okay. And what's the input to the gain? Just
Just a
One.
constant block.
Yeah.
okay.
Okay.
Yep.
Hello.
Yeah.
Okay. Now
Okay.
you need beta. See here, this is the beta. Okay. See here, if you look, we need to create a road profile, and from the road profile, you'll get beta. See here.
Mm-hmm.
What is the beta? Sorry.
Beta is the angle when you write a when you draw a tangent at the center
Oh,
of
yeah, that is
gravity.
the
Yeah,
okay.
this is
That's the
beta.
tangent line
So
at the contact point on
yeah,
the
at
road.
the contact point on the road. So what you need to find, you need to have a road profile. To the road profile, you need to draw the slope or a tangent. Then from there, you'll get the beta, right?
Mm-hmm.
Guys, can you see it? So our aim, what is our aim, is to define a function, okay, which tell us what is beta, which will tell us what is beta. So if you see here, it is very simple. Now imagine like the road profile is in uh, right. How to tell it in a better way. Okay, so if you see here,
But
Narendra, we are not seeing anything from you.
yeah,
what happened?
They're not sharing. They're not sharing the
Not here.
screen.
Oh, okay, sorry. What happened? Okay,
0 meters, 2000 meters.
okay, can you see it now?
Yeah,
Yep.
yeah.
Okay,
yeah.
so now this is like the vehicle here. The vehicle is moving in this x direction. Okay, then you'll have another speed in this direction. It is called floor speed. So this is xf. Okay, float speed. Now and so here this is xf. Okay, this is xf. Okay, and this is the actual x, the direction in which the vehicle is moving. So and this is okay, dyf. Oh sorry, yf. This is yf. Now okay, now
That angle is beta.
yes, yf, and this angle is beta. Okay, if you observe here, so what is like now if you consider a small part like dxf from here until here, maybe you can think it as dxf, like a small portion, or delta xf, whatever you call it as. Okay, then this will be delta yf or dyf, like a small portion of y. Then what is this x? X is nothing but root over, okay, dxf square plus dyf square, right?
Yeah.
Okay, so x you can get it by, if you know dxf and dyf. Now, so the road, for the road profile, what you need to do, all you need to know that y is nothing but a function of x. Like, see, uh, if you look at the equation, see, y x of f and y of f. So uh, y y of f is like, for example, if you take a, imagine the road is a sine waveform. Okay, the road is like, imagine the road is in the shape of a sine waveform. So if this is xf, okay, this is xf, then what is the road profile? Sine of x of f, or it is equal to y of f, right? Y of f is equal to sine of x of f. Now let's take this function. Imagine this is the road profile. From there, we will find out what is x, or from there we'll find out what is beta. Instead of giving the beta value, what I am doing is I am just trying to create a road profile, like shape of the road. Okay, how I am doing?
Mhm.
X of f is the flat, like this one is x of f, or you can say floor distance or floor speed, they call it as. Then the road profile I'm defining it. Oh, my road is like this, because sine function is the one which I'm familiar with. The road might be, Narendra, how can the road be sinusoidal? The road might be like this, okay, but I don't know what is the function for this. So I'm taking a sine function and I'm saying, okay, x of f is is the x-axis, y of f is my road profile. Okay, now here I need to create a road profile. Where is here? So here, so x of f and y of f. So let me create a road profile for you. Okay, go here and bring a another MATLAB function. Okay, and rename it as road profile. Guys, can you see me? Can you
Yep.
see the screen?
Yep.
Okay, road profile. I need to create a road profile for this. The name of the function is, yeah. Now, what are the inputs to this one? X of f is the input. Okay, output is beta. So output is beta. Okay, input is x of f, floor distance.
And how did you open another page of these functions?
Just type MATLAB function. That's it.
Another one, basically. Yeah.
So what did you have inside Narendra in the beta function?
Just I didn't find beta yet. I need to find.
Okay, you need to find it. Okay.
Okay. See, beta is equal to tan inverse of dyf by txf. That's it. All I need to do is this
Uh,
function.
Okay.
is there a
Beta.
way to cancel save? I'm
Huh?
stuck in save. Is there a way to
Uh,
cancel save?
Still, I didn't get you. Sorry.
I tried to save that model basically, and I'm stuck.
Oh,
I cannot do. Is there
uh,
a way to cancel the save?
no, no,
I
there
click
is
save
no.
as basically, but it's still
Uh,
circling, going.
okay. You need to give it some time. Your internet speed might be really bad. That's the reason why it is doing it.
Okay.
Okay.
Narendra,
Okay.
here,
Uh,
this second window, the function beta, whatever you wrote here, how will we open this new window? So that's what I stuck.
out.
I'm not.
Okay. Oh, here. See. Again, I got a MATLAB function. Okay. Just type MATLAB function. You'll get a MATLAB function. Okay. Now double click it. Then you'll open it.
Okay, thank you.
Okay. This function, I'm naming it as road profile. Profile. Okay, inputs, I'm finding it from the block diagram. Okay, x of f, output is beta. xf, okay, output is beta. Beta. Okay, now I need to find the calculations for beta. It is very simple. It was given here. Okay, so just give that function, then it is fine. So y of f, any function, right? We thought of sine function. So y of f is equal to sine of, okay, sine is nothing but a sine, right? So amplitude into sine of, okay, x of f. So frequency into x of f. A sine omega t. Omega is frequency, t is the time period, right? This is how the original function will be a sine omega t. Omega is frequency, t is nothing but x of f. A is amplitude. Okay, this one a sine omega t. So I have x of f and y of f. Okay, I need to define amplitude. Okay, for now I'll keep amplitude equal to 0 and frequency you can give maybe 1. Okay, frequency in x-axis. So okay, now I have x and y defined. Now find this one delta y of f by x of f. So it's very simple. How do you find differentiation? Yeah, see, this is a good lesson. See, how do you find differentiation in programming? Like integration, you have a function integrator. But how do you do differentiation in programming? It is very simple. Differentiation is nothing but is nothing. See, if you say uh, d x of f by dt, it is nothing but delta x of f by delta t. So it is nothing but a difference between two intervals. Like what do I mean? What do I mean? For example, this is the one. Okay, so you want to find dy of f by dx of f. That means you need to find delta y of f by delta x of f. So you need to take a small interval, this interval, okay, and during that interval, how this function is varying. So this is your delta y of f. This is your delta x of f. So from here to here, so you need to define this interval. Then you can find the differentiation. So in this program or in this block, what you need to find, you need to find differentiation dy of f by dx of f. Okay, that means you need to define an interval, and in that interval you need to find delta f and sorry, you need to find delta f, delta y of f and delta x of f. So how do you find that interval? What, okay, Narendra, you said, but I only know y of f, but I don't know delta y of f. See, again, it is very simple. Now it is so programming is very simple. So it is, we know this is x of t. Okay, imagine you are here. Okay, and you are traveling in this direction, in horizontal direction. Okay, you are traveling. Then after certain time, like same way as I said here, like what did we do for the derivation? We are saying when delta r moved from this to this position by a by an angle of zeta, I said, right? So that's why we did plus zeta. Then the function changed as sine of theta r plus zeta. So the same logic we will apply here. Like from moving from here to here, think of it that interval as 0.01, depending upon how your microcontroller, how your software can handle this interval will be varying. Okay, here MATLAB 0 for 0.01, my MATLAB will not cause any problem. So when, if you know x of f here, okay, then at this point x of f plus 0.01. That's it. So y of f here will be a sine x of f. Here it will be a sine x of f plus 0.01. Now you need dy of f by dx of f. So you need difference between these two. That's it. This function minus this function minus this function. X of f plus 0.01 minus x of f. That's it. So that's how simple you do how we do derivation in a MATLAB. If you still feel okay, this is more, then you can do just 0.1. Then your computations will be much faster. So we know what is y of f. Okay. So let's define uh, define some small interval, or let's define dx equal to 0.1. Some small value, to make it much simpler, to make calculations very simpler. Then dy delta x or delta y, right? So dy is equal to amplitude of this, okay, plus dx. That's it. Minus without anything. This is nothing. Now you know dy, now you know dx now. Okay, dxf dyf. Sorry. Okay. Now, if you want to find, go to the notes. Now, if you want to find beta, beta is nothing but tan inverse, okay, dyf by dxf. So beta is equal to tan inverse is a tan 2 in MATLAB function, a tan 2 by dy comma dx, dyf comma dx. That's it. That's how simple it is. Differentiation dyf by dt. If you know the functions, this is how you perform. Okay, you get beta here. Yeah. Okay, yf, I didn't use it. Okay, I defined yf, but I didn't use it. So that's why it is showing that, but it's okay.
Why we have doesn't underline? I don't know. We
What?
also
What?
have the same thing. So for the YF, you don't have a semicolon there, Narendra.
Which one? Here,
The
yeah.
YF.
And I also didn't use it. I defined the
Yeah,
function, but I didn't use it.
okay.
Okay. Yeah. So we finished the tough part. We will finish the remaining stuff tomorrow, guys. Okay. Let's stop here for the day.
So we'll save the model